Well, hello everybody, and welcome back to the radio shop and our Kenwood TS 520 SE series. And this time on the bench we have the Kenwood antenna tuner, and this is the model AT-200. Now I'm checking the antenna tuner out, and we can see that our antenna switch here works with no problem. The band switch though, once we come off of it and we get down to 14, it will not turn any further. So we're going to crack this thing open and see can we get into the video with it and see if we can get this thing repaired and find out why this band switch is not going past 14. If I play with it, I can get it to go just about on 21, but I don't feel like it's locked in then, but it won't go no further. And I'm not going to force them because I don't know what's going on inside. So we'll get this in there and go through it and see what we can find. Okay, we got all the screws out. Now we're ready to go ahead and remove the top cover. And we can get in here and see what's going on. Now, as I expected, you won't find a whole lot of electronics going on in this antenna tuner. Everything is mostly coils and mechanical. And as you can see here, we have two big air variable capacitors. The small coil here, and there's a large tank coil here. We have a big inductor, and we'll turn around on this side, and you can see there's a 2-gain wafer switch here for our antenna select switch, and 2-gain wafer switch over here to select all different taps for each band. So each band has a certain amount of coils that are used for the inductors to tune with. And we got a little board here on the front for our switch network and our calibrating trim parts. And then down here in the bottom you'll have a few capacitors and a couple inductors and a diode here and a couple of diodes over here, and that is for our metering circuit. So since our band switch don't want to go past 14, so you can play with it and get it down on 21 megahertz, but it's impossible to go to 28 megahertz. So the only thing that we have in that range on that shaft, you can see that shaft coming through there underneath those coils, and there's 2 wafer switches down here, and it's a little bit hard to see, but you can see them right there. There's a couple of wafer switches. If I turn it around, you can see them a whole lot better. And as I turn, let me try to turn this. Yep, I can see the problem. This last wafer switch right here is broken just under the support studs, and that's where the problem is. And it has one of these, this little terminals around the wafer switch, and I can see one of them down there that is bent around, and that is what the rotor, the end of the rotor, is hitting and stopping it from turning. So the next thing is to figure out, the best way of getting down in there to attack this problem. This one switch is at the very bottom of the whole assembly, as you can see. So I'm thinking take out these side screws on the bottom cover, pull out all these screws on the bottom. That'll take our brackets loose, and go ahead and take the bottom cover out, and we should be able to, you know, get good access to the bottom of it, and be able to get to it and see if we can't figure out a way to repair or replace that wafer. On the back of the antenna tuner, you'll have a your input. This will go towards your radio, and then you can select either dummy load antenna 1, antenna 2, or a long wire. And it's always a good idea whenever you're running an antenna tuner, especially a small one like this, is to always run a good ground. So you know it'll help balance out the tuner if you got a good ground. But as you see, it's very, very simple. Just a lot of wiring and coils. Not a whole lot to them. So when working on them, there's not a lot to worry about. And since it's automatic, you know, there's no DC power to be involved with or anything. Alright, we'll go ahead and get the bottom out and see what we can do to that switch. Well, I wanted to get in here and look at this AT-200 antenna tuner and see what we're going to have to do to fix this broken wafer switch. And you know, that's pretty much going on inside as far as mechanical connections. There is a lot of wiring inside, as you can see, that's going to that wafer switch. So at this point, I'm thinking the best thing to do to get in there to make some room so you can work on it is just go ahead and remove these screws out of the bottom and remove all the screws here, and go ahead and get this bottom cover out of the way. Now it's going to leave everything inside kind of floating, so you got to work kind of carefully. But maybe we can get in there and desolder all this stuff and get that switch or that wafer, so we can get in there and see if we can repair it or replace it. Okay, I have all the screws removed. We have the unit sitting upside down. Now we should be able to lift this bottom cover off. And now, as you can see, everything is a lot more exposed, and we can move around in here and see what all's going on. And I can see the break a lot clearly now in this end wafer switch. And you can see it right down here in that corner right there, just underneath this bolt that holds everything together. Everything on it is pretty tight at this moment, with all these wires that you see that's running right down here going to the top of that wafer. So I'm gonna have to get all those desoldered, and that'll loosen up that wafer. Now before you go do this, make sure you take plenty of pictures so you know which wire came from which tab. I came in here and desoldered all the wires off the coil up here that goes down to that wafer switch. And as you can see, I got the broken part of the wafer switch off. I marked one end with black, and I've looked and I do not have one of these. So I think what I'm going to do is clean this up real good. Go ahead and take the rest of the wafer switch out, and mark the orientation of the rotor. See if I can focus on it a little bit. Yeah. There we go. So we've got no more wiring attached to this wafer switch. If I can get the right one in focus, you can see what I'm talking about. Okay. So there's no other wires attached to it. So all we should be able to do is break these studs, pull off this end cap, and slide this wafer switch off, and then look at it and see if we can repair it so it'll go back to work like it's supposed to. Now I'll try to zoom in on this. Get the camera to focus just right. And it looks like the only terminal that's going to be in question is this first one. You see it's bent just a little bit, but we'll be able to, and that's where that band switch was coming around and hitting here, and that's what was stopping it from going into the 28 megahertz position. So we'll see if we can straighten this out and get it back in line like it's supposed to. The rest of them look good, no problems whatsoever. Okay, as you can see, I have removed the two nuts that was holding the end plate on, and removed the end plate. Now we should be able to pull these little spacers right off. We'll put them in a container, and we should be able to slide this wafer switch out. Just ever so gently work it out to the end. And there's the bottom piece and the rotor. So this is what we have here. Now I'm going to set this down and mark everything so we know the orientation that it went in. Okay, so I got the wafer kind of assembled back together and got the terminal straightened out. So I think that would be able to work now. And all I want to do is kind of hold it together, stick a screwdriver in, and work it back and forth and make sure we got, you know, a good rotation without any binding. And it seems to be pretty good. So what I'm going to do now is go ahead and pour the broken piece back off and wash this thing up real good with some contact cleaner and then some isopropyl alcohol and get it good and clean. I don't have a lot of material here to work with to epoxy these back together, but we're going to give it a try, and we might have to come in here and put something here to it can't be metal because we can't ground out, because this is going to be on a ground plane. We can't ground this out, so it's going to have to be isolated. But we'll see if we get it epoxy back together after we get it cleaned and see if it'll hold up. Now I've cleaned the Bakelite wick, broken it. So now we just got to let it dry, make sure it's good dry. I might put a little bit of heat on it also, and go ahead and make sure we get all the moisture out of this before we epoxy it back together. So I'll go ahead and do that off cam, and we'll see how it ends up and looks. Okay, I used some 2-part epoxy and got the epoxy back together, and we'll let this dry for a little lengthy spell. and then we'll go in and inspect it and make sure everything is turning freely again, and then we should be able to reinstall it back into our antenna tuner and see how it works. Alright, we have our gear mounted back in and retaining plate back on and tightened up, and you have to be a little bit careful at doing this because you know there's nothing to hold it back. And now our wafer switch rotates without any problem. So another thing I was looking at that we need to take care of while we're working on this, and you always wonder how a wafer switch breaks. So let me show you a little something. Showing you a straight on shot here, and you can see this bracket here over here on this set of wafer switches, and you can see this bracket here that's on the wafer switch we just repaired. And if you look at it, put something on it, you can see it's at an angle. Now this bolts directly to the bottom cover, so that is, when it bolts down and bolts tight, it's putting a little pressure on this shaft and connector, and so that could be what caused the wafer to break. So we're going to straighten that back out and see if that won't take care of the problem. Let's go ahead and move the camera so that I'm not completely blocking everything. And all we're going to do is take a pair of needle nose pliers and hold the bottom. Yep, that looks a lot better. Now the bracket is it's going to be square with the bottom. There shouldn't be no more pressure on that. So what I'm going to go ahead and do now is put the bottom back on here. And it's going to make it a little bit harder to get to our connections. But what we want is everything to be good and rigid and square like it should be. And then what we'll do, we'll bend our wires from our tank coil over to the contact and fix the wire so it's not, you know, we're not just going to pull it over and solder it. We'll actually bend it so it'll stay in place and stay at the contact, and that'll keep from putting so much strain on that little wafer. Okay, so now our wafer switch is all back together, everything's wired in, and as you can see, everything works real good. Watt meter seems to work. 200 watt scale. Good reflected. No reflected power. We're all on a dummy load. Okay.
Golf kilowatt, sorry again. Kilowatt Gemini kilowatt 5 and 9. Yes sir, thank you for QSO. Good luck. Charlie Tango 7 Special, Oscar Kilo 4, Papa America, KRZ. Kilo Fox 5, India Tango Mike. Kilo Fox question mark, India Tango Mexico 5 and 9.
Thank you sir, you're also 5'9" in the state of Arkansas. The name is Kirk, Kilo India Romeo Kilo QSL.
Okay, can you give me number in your prefix, Kilo Fox question mark again?
Okay, I was just listening on air with the tuner. You really need to have the tuner grounded when you're using it. And here on the bench I don't have a ground wire that I can get to. I do need to add that. Now the equipment is grounded, yes, but a good earth ground for the end tuner is needed, and again, I don't have that on the bench. But the tuner seems to be working good. You know, I didn't test it on air, but I did test it on dummy load. So if I go to dummy, we're on 14. I've got reflective power. Let me move the camera. Okay, I'll put the radio in the FM mode. Okay, I put the radio in FM mode, and we're using our FT747 for this demonstration. I got the power down. We're running through on antenna 1, but we're running that into a dummy, so it'll give a better response. I turned the power down on the radio also. We're going to calibrate the SWR meter. Then we'll go to our reflected, and we'll go ahead and tune down the on the 14 megahertz band on the antenna tuner. And as you can see, we can zero it just about next to nothing there. Hardly no reading at all. Maybe about a 1. Yeah, so we look good there. And we put down about 40 watts. And that's all it took to get the antenna tuner back up and going. Just fixed that little problem with the wafer switch. Now, if this was in for a customer, I don't know if I would just glue it together and let it go out like that. I would probably go in there and reinforce it a bit with some more bait light, probably with some perf board behind it, and just epoxy it all in. Using it myself, you know, and you're here in the shop, it's no problem. But you know, letting it go out to a customer with it just glued, and you know, it's just a very small amount of that switch on both sides. I mean, that bake light that was epoxied back together. I kind of wouldn't want to trust it, you know, giving it back to a customer like that. But for myself, it'll be fine. Later on, I might go back in and add some reinforcing to it, but it should be fine, just like it is. I'm also experimenting more with another camera also, just for capturing some of the work. And as you can see, there's a camera pointing down at the workbench, and it is on this tripod that's sitting right here. Just a little small webcam, you know. So I'm just checking some things out with it, and I might be adding some picture-in-picture type stuff in some of the future videos, but we'll see how that goes. So anyway, we concluded the AT-200. It's up and running. Probably one of the next pieces I'll be working on is the digital display. It does need a little bit of rebuilding, and you know, change out some of those capacitors and check some solder joints. Anyway, I hope you enjoyed the video. If you did, give me a thumbs up. You know, kind of a quick repair. I didn't have a whole lot to do with it, but it should be good to go now. Anyway, we'll catch you in the next video. See you now.